right, we are going to look at a practice problem that reads, in 2 minutes, a ski lift raises 4 skiers at a constant speed to a height of 140 meters. The average mass of each skier is 65 kilograms. What is the average power produced by the tension in the cable pulling the lift? So we want to determine the power of that cable pulling the lift of these skiers being raised up at a constant speed. All right, so let's sort of just, well, we want power, okay, so we know that power is related to the work divided by the time. We're told that that time is 2 minutes, so time is equal to 120 seconds, so 2 minutes is 120 seconds. So what we need to understand is what is the work produced by that tow rope. All right, we know that if we imagine the ski lift, I mean, it's going up the side of the mountain, right? So here's the side of the mountain that this tow rope is carrying those lifts up, but we know that it raises the skiers a height of 140 meters. So we don't really care about that. We know that the average mass of the skiers is equal to 65 kilograms, and there's 4 of them. So what we want to know, so the total mass of the skiers, is it 65? Yeah, 65. Times 4 is 260 kilograms. So we need to know what is the work. In order for us to determine the power, we need to know the work. And we know that the work is equal to the force times D times the cosine of the angle. So let's do a work analysis on these skiers and this tow rope. Imagine that we look at a free body diagram of the skiers. Now we can dissociate that free body diagram and it's not necessarily sliding around a ramp. We know nothing about that. We don't really know how it's how the contraption looks, but we do know that the work is whatever that force is being exerted times the distance it's being exerted. And it's the work is the force relative to the distance direction. We know that the distance direction is in the vertical direction, okay? So the component of the force by that tow rope has to be the component in the vertical direction, all right? So the component has to be the component in the vertical direction. So this is the tension of that tow rope in the vertical direction. There's probably also a tension in the horizontal direction. I just don't care about it because I'm looking at the work being done. And that's going to be, this has to be in the vertical direction. Okay? All right, because that's what I'm given. I'm given that 140 meters. So we know in the vertical direction we have the tension, the vertical component of the tension, and we also have the force of gravity on those skiers. Now, it tells us that that tow rope is raising those skiers at a steady rate. So if there's a steady rate, the sum of the forces has to be equal to 0 because the acceleration is 0. So if we look at the two forces acting in the vertical direction, the direction I care about, then we know that, here's my vertical direction, we have the positive component of the tension in the vertical direction plus the force of gravity, which we know is in the negative direction. And we get the vertical tension is equal to mass times gravity. Now our mass in total is 260 kilograms. So the vertical component of the tension has to equal 2,548 newtons. And it's that vertical component that's doing the work, okay, doing the work. So then we can use this vertical component into our work equation. 2,548 times the distance vertical that we're doing, 140, and we get a total work of 356,000, I'm not rounding yet, 720 joules. And we know that is done, so if we go to our power again, we know that the work, 720 is divided by 120, and we get 3,000. Once I round, well, I'll give you the total number. The total number is 2,973 watts, which is about equal to 3,000 watts. This is a squeaky marker. 3,000 watts. All right, so a couple things to recognize in this type of a problem. We appreciate that power is the work per time. We want to remember that work is always related to the force being done in the direction of the displacement. We are given that the tow rope raises the skier 140 meters vertically. So it's the vertical component of the tow rope that's doing the work. So we can do a force analysis on the ski lift looking at the vertical components that are doing the work. So keep in mind this is forces in the direction of the displacement. So the force is doing the work, right? Okay, so those are the two forces that are doing the work on the object. We're interested in the force, the power of the rope itself. So we're interested in the force the work that tow rope is doing, and then we can use our power relationship. All right, so recognizing those pieces and the relationship between work and power and force. Good job.